The first one says, sorry, hold on. The first one says, determine which of the following is a parameterization of the line segment with endpoints at A equals 2, -3, and B equals 1, 2.
Alright, let's see. There is a section that does these exactly like this. Find the parameterization of the line segment with endpoints. Oh, in my book it's -2, 3 and 3, 6. Okay. Well, hold on a moment. I'm trying to figure it out myself here. All right, the way they do it is, well, let's draw a graph here. I think it'll make more sense.
Okay.
This is O. A is right here. B is right there. So they have that vector as OA. They have this vector as OB. And one moment. Yeah, this is really strange, crazy. Hold on. Let me do the one they've got in the book, and then we'll figure out how to do yours. It'll make more sense. Let me make A -2 + 3, and let me make B 3, 6, and we're going to work with this problem, and then once we figure out how to do this problem, we'll know how to do yours.
Okay.
Now, we can use vectors to help us find parametric equations for a line as illustrated in this example. And they've got their A right there, that vector. They've got their B right there, that vector. And they place, this is the part that's hard to understand. If you extend this vector in this direction and you connect that with some point P, which has the coordinates x, y, then OP minus OA equals AP. That makes sense, right? If we're just looking at vectors, OP minus OA gives you this AP.
So do we just make up the coordinates?
Well, hold on. We're not done yet.
Okay.
Then the vector AP must be a scalar multiple of OB OB minus OA. Oh, yeah. If OP vector minus OA vector is equal to the AP vector, which it is, then it has to be true that the OB vector minus the OA vector has to be a scalar multiple of AB. All right, let's go forward and maybe it'll make more sense to us.
Okay.
What they next do is, since OA, the OA vector is minus 2 comma 3, the OB vector is 3 comma 6, then the OP vector we know is x comma y, right, from our picture. In other words, I'm just saying P is some point on the extended OB vector. So the coordinates of the OP are x comma y. Now, this is the next step that is a little tricky, and that is that this is what makes it all make sense. If I take my original OP minus OA vector, then that has to equal some scalar multiple, T, times OB minus OA. And the OP vector is x plus 2 in other words, this becomes x plus 2 comma y minus 3 is what OP minus OA is, right? In other words, if I said what's OP minus OA, you would subtract, it would be x minus the minus 2, or x plus 2, and it would be y minus 3. So this vector represents OP minus OA. And we know that that is a scalar multiple of OB minus OA, which is 5 comma 3. All right, it follows that x plus 2 must be equal to 5t, and y minus 3 must be equal to 3t. And there's your parametrization. In other words, x is equal to 5t minus 2, and y is equal to 3t plus 3. All right, so let's do your problem.
Okay.
The only difference in your problem is this is a positive 3, negative 2, correct?
No, it's 2, negative 3.
2, negative 3, okay. And this one,
that's 1, 2.
all right. So let's skip down to this equation here is where we want to pick it up. OP would be x minus 2. In other words, let's see, what's the best way to do this here? Let me erase this. So we're going to say the vector that represents OP minus OA, remember OP is x and y. So the vector that represents OP minus OA must be x minus 2, comma, y plus 3. That's the vector OP minus OA. That has to be some scalar multiple of the vector OB minus OA. Well, what is OB minus OA? Just subtract individual components.
All right. Okay.
That is going to be 1 minus 2.
Okay.
Negative 1. What's the y component?
That'd be 5.
Huh? And from there, you're off and running. In other words, I can now say, therefore, that x minus 2 equals negative t, and y plus 3 equals 5t. It's as simple as that. The actual mechanics of it are as simple as this. You don't really need to understand this part here, which is very confusing to understand.
Okay.
Yeah, it's not that confusing.
Do we need to get like x and y by themselves?
What's that? Oh, yeah, that's not the final answer. Well, I mean, it is. You could say that that's a parametric equation. It's just not x equal. So this would be x equal 2 minus t, and this would be y equals 5t minus 3. Notice that these are parametric equations with t being the parameter. And they did add one other thing here, that means t is going from negative infinity to positive infinity. And that's because on my original picture, this p can be anywhere. I could have made the p way up here. I could have made it 100 miles further along that vector. And it doesn't matter. The concept is kind of the same here. OP minus OA has to be a scalar multiple of OB minus OA. And that's basically what they're saying when they get to this step here. OP minus OA has to be a scalar multiple of OB minus OA. And then we just fill in what we know. OP is x, OA is 2, minus 2. So OP minus OA gives you this for the x, this for the y. OB minus OA gives you that for the x, that for the y. And then you go from there.
Okay.
The real key is introducing OP with coordinates x comma y. In other words, I introduced the point P that had coordinates x comma y, and now I can figure out what OP is, minus OA. It's just x minus that x coordinate.
Okay.
And y minus that y coordinate. That's what OP minus OA is. All right. You think you got it? How many more problems do you have to do to fix tonight?
Well, we have until Monday to do them, so
Okay.
I'll probably schedule another appointment because I have quite a few. So.
Okay. You want me to give you another one here and let you do it by yourself? Try.
Yeah,
We can do it real quick. I'll just make up some.
Yeah.
2 vectors. A is going to equal or reside at 4, 7. B is going to be at -2, -3. Parametrize those.
Okay. So we would start with. So we just set P at XY then, right?
Right. So what would OP minus OA be?
So that would be X minus 4.
Okay.
Y minus 7.
Okay, that's OP minus OA. That has to be equal to what?
OB.
A scalar multiple represented as T times which vector? OB minus OA.
Oh. Okay, so do -2 minus 4, so -6. And -10.
Now it's simple algebra. In other words, once you get this step, the rest of it falls into place. Just distribute the T and let this equal that, and let this equal the T times the -10. So you would have x minus 4 equals -6t. There's one parametric equation. Y minus 7 equals -10t. There's the other. You can simplify them if you like, but we've got the answer there.
Yeah.
So it's really a rather simple process. It's always x minus 4, or x minus the coordinate of the x coordinate of A, y minus the y coordinate of A, equals t times b minus a, y minus that y. If you remember just that methodology, then these are easy, even if you don't understand the concept behind it. The concept, granted, is a little strange, a little hard to understand. The concept being this concept here, as to how we end up with this P. But these two equations are what are important. Okay, what else you got?
Next one is find an angle theta in 0 is less than or equal to theta is less than or equal to 2 pi. That satisfies both sine theta equals -√3/2 and cosine theta equals 1/2.
Okay. This is actually pretty easy. This is just a standard trig problem.
Oh.
Where is I mean, maybe they want you to do it with vectors, but we don't need to. Where is the cosine of theta equal to 1/2? What are all the possible angles? That's 60 degrees.
Oh.
So that would be pi over 3 is 1. Where else? What quadrant is it positive?
Oh, so that would be the fourth quadrant then?
So that's 5 pi over 3. So at these two angles, the cosine of these two angles is equal to 1/2. But only one of these angles is the sine of theta equal to minus square root of 3 over 2. Which one is it?
That would be the fourth quadrant.
5 pi over 3 is the only answer. It's the only place in all four quadrants where both of these two things are true. There's actually two angles where that's true, and there's two angles where that's true. But there's only one angle that overlaps both of them, or that is common to both. This is a simple trig problem to me. There may be some way to apply vectors to this to solve it. I don't know. I don't know why you'd want to. This is just a standard trig equation.
Okay.
I don't know. I've discovered a lot of things in the vector section where the book gives you a far more complicated way of solving it than appears necessary. I don't quite get why. I think it's just one of those things where some books don't always give you the simplest way. What else do you got?
Okay, so it says if u equals 3, 5, and v equals -2, 1, which of the following relationships is true about u and v? And there's 4 options. There's parallel, orthogonal, sisters, and none of these.
Okay. Let's draw UV, just so we can get a picture of it. There's the vector U. The vector V is right there. Do those look? They're certainly not parallel. What might they be?
Well, I got orthogonal, and that was apparently wrong.
No, it's correct. Oh, no, it isn't correct. What has to be true for this to be a right angle?
The dot product has to be 0.
Okay, what's the dot product here? It's -6 plus 5. Minus.
Oh.
So they're not orthogonal. They're not parallel. What was your other choices?
Sisters and none of these.
Sisters?
Yeah, I don't know if that's actually a thing or not.
None of these.
Okay.
I don't know what sisters are. So it may be just a word he made up so that you'd have to answer.
Yes.
I don't know. But they're certainly not orthogonal. We could figure out this angle. There's actually 2 ways to figure out that angle. There's the super complicated formula they give you in the book, but the way I much prefer is to figure out the direction angle, figure out that theta, figure out that alpha, and subtract the 2 of them. And figuring out that theta and that alpha is relatively simple. This theta here is the inverse tangent of 5 over 3. This alpha is the inverse tangent of 1 over negative 2 plus pi. That's going to give you two angles, alpha and theta. Subtract the two, and that gives you the angle in between, always. I don't know why they don't teach it this way. This way is far simpler than that formula they give you for the angle between two vectors, which is very complicated. I don't know where it is now, but and it's the same sort of thing when you project one vector onto another. It was only when I reread up on it that I realized that there's an easier way to do it than the way they list in the book. They use the real complicated formula to do projecting vectors onto another. Okay, what else you got? Can't even imagine what sisters would mean if I did know what it meant.
Yeah, I think I just think he just threw it in there to.
Could be opposites. In other words, maybe you have one vector going like that, and you have another vector going like that, but that would make them parallel. So that wouldn't be sisters. What other kind of relationship could you have? They're either orthogonal or they're parallel, or there's some angle in between them. So I think he made that word up. All right, what else?
Okay, so this one, the only part that I got wrong was the angle between U and W.
Okay,
So
let's do that.
U,
Let's do that using my technique.
okay.
Well, maybe. If he says you have to show all your work, you might want to use the formula in the book.
I don't think he cares too much so long as I get the right answer.
Okay. What are U and W?
U is -512, and W is 1/8.
1/8?
Yeah.
Okay. What's the angle between the x-axis and U?
The inverse tangent 12 over -5.
The fact that the denominator is negative means what? We have to add pi to this. Only add pi if x is less than 0. What's the angle between the x-axis and W?
Inverse tangent of 8 over 1, so just 8.
Okay. In your calculator, what's the inverse tangent of 12 over -5 in degrees? I'm going to change that to 180.
So inverse tangent of
-12/5. It's going to give you a negative angle.
5.
What is it?
Well, I got a positive angle, so I don't know if I put it in
You
right.
do inverse tangent. Here, I've got.
Oh, should I keep the plus 180 in the parentheses?
I don't know. Here, let me bring up my calculator. This the calculator you use?
Yeah.
Okay. Let's put it in degree mode. It's in degree mode. Let's clear it, and let's do inverse tan of, boy, it's hard to see these blue. Inverse tan of minus, I have to use that minus sign down there, 12 divided by 5. Doesn't matter whether I make The 5 negative or the 12 negative?
I don't think it does.
No, it doesn't matter. That's what I'm saying. So the answer is minus 67 degrees, but we have to add 180 to that because it's actually the 5 that's negative. So that gives us an angle of what?
112 or 112.62.
That's 112.62. And what's the inverse tangent of 8?
Um, 82.87.
So there's W. And this angle is 82.87. So what's the angle between them? Looks like 29.75.
Yeah.
No, 29.75.
No, you got it.
That's correct.
Yeah.
Now, that's an easier way to do it, I think, than the way they would do it in the book. They would have you doing dot products and magnitudes and all kinds of stuff. Completely unnecessary. It's always worth drawing a picture here because, first of all, you would remember that you'd have to add 180 to get that. Because if you don't add 180, you end up with that vector being down there, the minus 67 degrees. Or actually, it would be pointed.
Yeah, I forgot to do that on.
It would be pointed like that. That's why we add 180 if x is negative, is to get it into the right quadrant.
Yeah, I did that and I got 150.26 degrees, so I forgot to add the 180.
Okay. To me, this is by far and away the easiest way to find an angle between two vectors, is to find each angle with the x-axis and then just subtract the two.
Okay.
Even if this vector is way over here, notice that if that vector is in the third quadrant, both x and y are going to be negative. So you're going to be taking the inverse tangent of a positive number and still adding pi to it, because the inverse tangent of the positive number will put you in the first quadrant. After you add 180, gives you in the right quadrant, the correct quadrant. Okay, what else?
Next I have what is the trigonometric form of the complex number negative root 8 plus root 8i, where 0 is less than or equal to theta is less than or equal to 2 pi.
I'm going to have to look in the book to figure this one out, only because the reason he's letting you take this test over again isn't because he's such a nice guy. Let me guess, it's because everybody flunked it.
It's because the schedules have been all messed up and a lot of people flunked it, yeah.
Well, the fact is that vectors, parametric equations, and polar are the three toughest subjects of pre-calculus. They just are. And
yeah, and he wasn't even like he wasn't able to be in class for most of the days, like for the last 2 weeks, so he felt bad.
okay, yeah, that definitely doesn't help. All right, here's the formula. If z is equal to a plus bi, and that's the form we're looking at there, then the trigonometric form is z equals r times the cosine of theta plus I times the sine of theta, where A equals R cosine of theta, and B equals R sine of theta. And R equals the square root of A squared plus B squared. In other words, these are all the polar equivalents when you're going from xy coordinates to polar. Remember, x was equal to r cosine of theta, y was equal to r sine of theta.
Yeah.
Well, now, and r squared was equal to x squared plus y squared. So these three identities here are no different, really, than the polar forms of a rectilinear equation. So, hold on a moment. So first of all, R, in order to put it in this equation, we're going to need R. R is the square root of A squared plus B squared. So what is that?
So that'd be 8 plus 8i? Or,
Yes.
oh, would that just be negative 8 then?
Yes, 8i squared. Hold on. No. Here, let me rewrite this. R is the modulus of our complex number. First of all. Okay. And how do we find the modulus? We square that, and we square that, and we take the square root of those. So it's the square root of negative 8 squared, which is 8, plus the square root of just this part, which is another 8. So R is actually the square root of 16, which is 4. And that's all we need. So our answer is 4 times that. Now, hold on. Because the reference angle for theta is minus pi over 3, the book does it slightly different than I do it. Okay, this isn't the answer. We got to come up with what theta is.
Okay.
In my example, they're doing square root of 3 over 1, which is, what's the inverse tangent of that? That has to be 30 degrees, which is, we can figure out theta exactly the way we figured it out before. Theta is going to be the inverse tan of B over A if a is greater than 0, and it's going to be b over a plus pi if a is less than 0. Well, in this case, that means the inverse tan of square root of 8 over negative square root of 8. Since the negative is in the bottom, we got to add 180 degrees to that. And that is minus 45 degrees, which means after we add 180, we're at 135 degrees. So for theta, I can substitute 135 degrees or its radian equivalent. Let me just make sure. Hold on. Yep. No, that's exactly the way they do it.
Okay.
That's the way we want to do it. This concept of this inverse tan is nowhere in this book. I can't believe it. It's fundamental to so many vector problems and this trigonometric form of a complex number. Basically, what you want to do is treat that as x and that as y. And then you'll figure out r based on that, and you'll figure out theta based on the inverse tan of y over x. Let's do another. This one I'll let you do.
Okay.
Here's the point. So, we know that the trigonometric form of this complex number is going to be, they use z. It's going to be r times cosine of theta plus I sine of theta. Well, first thing, what is r?
So that's going to be the absolute value of -3 minus 4a.
Now, think of this as x, and this as y.
Oh,
So r is the square root of x squared plus y squared.
okay.
That's a 3, 4, 5 triangle. So r is 5. If I take the square root of -3 squared plus -4 squared, I get the square root of 25.
Okay.
What's theta?
So it's the inverse tangent of -3 over -4.
Y over it's y over x.
Oh, -4 over -3.
Give me that on your calculator. What is that number? And do I need to add 180 degrees to it?
Yes.
Only because the bottom is negative, not because of the top. Regardless of what the top is, I've got to add 180 degrees if the bottom is negative.
Okay. So that gives us 233.
There's theta. 233 degrees. Or 4.07 radians. It's as straightforward as that. It doesn't get any simpler than that, actually. And remember that we have to put theta in there and theta in there, but leave the I. And they do. No, they give the final answer as, ooh. Oh, because they rounded it off. They give it as approximately. In other words, they say this at the very end, that minus 3 minus 4i is approximately equal to 5, that was r, times the cosine, and this needs to be in radians. That's, how many pi is that? I multiply that by pi over 180. I get
233. 4. That's 4.06.
That's what they put in their book. They don't put it in terms of pi. I'm not sure why. You would think that they would put it in terms of 233 pi over 180. That's the way the book writes it. Now, the only reason this says approximately is because the 4.07 is rounded off. Your calculator said 4.06, but it rounds up to 4.07 according to my book.
Yeah, there's more digits behind it.
Now, had they put 233 over 180 pi instead of that, they could have used an equal sign. Okay, what else?
The next one is, okay, give the parametric equations, or given the parametric equations x equals t squared minus 3. Sorry. And y equals t plus 2. Eliminate the parameter and write the equation.
Okay. What's the easiest one to solve for t?
The y. So that'd be y minus 2 equals t.
And that's what you substitute into the first one. In place of that t right there. So it's y minus 2 squared minus 3. There's your, I've eliminated the parameter. That's really all the further you need to go. Very simple. Just solve one of them for t and substitute.
Okay.
Okay. The only hard ones are the ones involving trig functions. Those are the ones where you have to kind of think out of the box. If you got cosines and sines, you need to solve, instead of for t, solve for the cosine of theta and the sine of theta. Then square both sides, add the two equations together, and you lose the variable theta, because cosine squared plus sine squared equals 1. So these are quite easy to do. There can be some domain considerations here. If you have a certain type function where the domain is restricted in the x, and by the time you've eliminated the parameter, there are no more domain restrictions, well, the domain restrictions follow. In other words, if there are domain restrictions, you have to include them in your final answer without the parameter.
Okay.
In other words, if I had something like x is the square root of t, well, now the domain is x has to be greater than or equal to 0. Well, by the time you eliminate the parameter, you might end up with something like that where it doesn't look like there's any domain restrictions on x. But there are. X still has to be greater than or equal to 0.
Yeah, well, the next part of the question is to name the endpoints. Is that where you're kind of going with that?
Did they give you, what was it, t squared minus
T squared minus 3.
Did we give a domain on t?
Well, now, it's, name the endpoints if negative 2 is less than or equal to t is less than or equal to 2.
Okay, so there's one endpoint, there's another endpoint. So plug in, once we turn this into x equals y minus 2. Now we got to go back to the original equations, these two. Plug in t of minus 2. What do you get for one endpoint?
So do I have to do each equation individually? Okay, so that would be 4 minus 3, so x equals 1.
Okay, so 1, what's y when t is minus 2?
Y equals 0.
There's one endpoint. Here's the other endpoint coming. Substitute 2 for t.
So x equals the, oh, okay, so
1 comma 4. So those are your two endpoints. In other words, when we got our final answer, we had x equals y minus 2 squared minus 3. There's our non-parametrized parabola. That's a horizontal parabola, something like this. And one endpoint is here, and the other endpoint is up there. So maybe it's a parabola like that, something like that. In other words, when you have a parametrized set of equations, you can trace that graph out. I know it's a parabola, but where does the parabola start and where does it end? Well, it appears to start right here at 1 comma 0, and it appears to end up here at 1 comma 4. It opens to the right, so it would draw like this. If you put it in parametric mode and drew it on your calculator, it would look like that. If you had arrows, those arrows would go like that.
okay.
So it's not quite correct to say that this is the answer to this, because this would go to infinity in both directions. Whereas with t being restricted from minus 2 to 2, it doesn't go to infinity in both directions. It goes just between those 2 points. That's the entire curve that goes with this curve here.
Okay.
Yeah, and that's right. That's a vertical shift of 2 units up and 3 units to the left, which is exactly what this thing looks like, as opposed to the parabola. That's x equal y squared there. All right, what else? We got 3 more minutes tonight. Do you have a short one?
Not really.
No. Do you have another one? Why don't you give me your next one, and I'll see how long it's going to take.
Okay, it says, given the parametric equations x equals 5 plus 2 cosine t and y equals 2 sine t, eliminate the parameter and write the equation in a recognizable form.
Okay, this is good. This is fast.
Okay.
Did I get it right?
Yes.
Okay, so our goal is to solve each equation for the trig function. Solve that equation for that, and solve this equation for that. What do you get?
So x equals,
We're going to solve it for cosine of t.
oh, okay. So x equals, or cosine t equals, x minus 5 over 2.
Okay, now y? Sine t?
That would just be y over 2.
Now, if we square both sides and add these two equations together, the right side is going to end up being 1. Right? That's always the next step. Square both sides. It's not obvious. You got to do it a few times before you remember that's how you solve these. Took me a while to figure it out. Now, add the two equations. The right side becomes 1. The left side becomes x minus 5 squared over 2 squared plus y squared over 2 squared. What's that the equation of?
Is that a circle?
Because both denominators are 4, I can multiply both sides by 4, and I end up with that, and that's a circle whose origin is at 5, 0, and whose radius is 2.
Okay.
Gets slightly more complicated if this number is different than this number. Then you end up with denominators that are different. You may end up with a 4 there and a 9 there, and you still have your 1 over here. What's that the equation of?
An ellipse.
Yeah. So whenever you have different coefficients in front of the cosine t and the sine t, irregardless of this, you have an ellipse. So if I had something like x equals 3 cosine of t, y equals 4 sine of t, you still solve both for just those. You still square both sides and add them together, but you can see that this is going to be x over 3 squared, so it'd be x squared over 9 plus y squared over 16 equals 1. That's an ellipse.
Okay. Sorry, back to the circle. The next question was actually, I think you mentioned the answer. So what was the origin of the circle again?
5, 0.
Okay.
Because
And the radius was 2?
the radius was 2, yeah, because I ended up with a 4 on the other side, and it's always equal to the radius squared. So the radius is the square root of whatever number ends up on the right side.
Okay.
All right. Daniel, I need a check.
Yeah, I sent it today, sorry.
Okay, good. And what, you want to schedule something now?
Yeah, sure.
When
Let's
is this due? By next Monday?
Yeah.
So the Tuesday night won't work.
I mean, we could do something tomorrow, right? Is there anything open, or?
This is my tomorrow.
Okay.
I'd rather do Thursday. I got a lot more opening on Thursday. Does Thursday work for you?
Yeah.
Same time? Or a different time? You can pick whatever time you see available there. 5 o'clock or later.
Yeah, we'll do the same time, 7:30.
Okay. Wow, I've had a lot of Daniels. All All right. I'll talk to you at 7:30 on Thursday.
Cool.
Okay?
Thank you.
All right. Bye-bye.